Half-value thickness. For a particular energy of radiation, a certain thickness of certain material will reduce the intensity by half. This is known as the half-value thickness, and it depends on the type of radiation, be it alpha, beta or gamma, and on the energy of the particular particles or photons being emitted, and of course also on the absorbing medium. Here we have a slab of material of the half-value thickness, and if 100% of the radiation enters on the left, only 50% will exit on the right. If we have twice the half-value thickness, then 100% entering will reduce to 50% when it gets halfway, and the 50% at halfway will have reduced by half again to just 25% at this point. So the intensity falls off exponentially. This leads us to this relationship, where I is the intensity after travelling through a material of thickness x, I naught here the intensity at the start. Mu, which appears here, is a factor that depends on both the absorber and on the radiation, both the type and its energy. And x here is the thickness of the material that the radiation has passed through. At the half-value thickness, the intensity will have dropped to half of what it started from, so I over I naught is equal to a half. From this we can write that a half is equal to e to the minus mu x h, where I have indicated the half-value thickness as x with the subscript h. So we can invert both sides and get that 2 is equal to e to the mu x h, where inverting a half gives us 2, and inverting this removes the minus sign. Taking natural logs of both sides gives us the natural log of 2 is equal to just the power here, mu x, of the half-value thickness. We can rearrange this to give the half-value thickness, x sub h, is equal to the natural log of 2 over the coefficient of absorption, mu. Taking natural logs of both sides of this equation, we get this, as the natural log of e to a power is simply the power. Rearranging to this format, we now have a variable is equal to a constant times a variable plus a constant. So this is of the form y is equal to mx plus c. So if we plot a graph of the natural log of the intensity I against the thickness of material travelled through x, we should get a straight line with y-intercept equal to the natural log of I naught, the intensity of the radiation entering the material, and the gradient will be minus the absorption coefficient, mu.